In the sixth exercise, we are asked to write the strlen function, to write a function that calculates the length of a string. We can provide a string in the data section, and we should write a function to calculate the length. Now, first of all, the data section. So this is how you write a string to the data section. This will also reserve space for the null byte. So what the string instruction will do is it will count the amount of bytes here, 1, 2, 3, 4, 5, add a null byte, 6, and then it will round up to a multiple of a word size. So 6 rounded up to a multiple of the word size would be 8, which is 2 times the word size, which is 4 bytes. So it will reserve 8 bytes, and it will then store these letters right in there. So if we look at this data section, when we assemble this, right here is a string. This doesn't mean much, but if we put hexadecimal values, now you can see why hexadecimal values are so valuable. You can see the individual bytes stored. And the individual bytes, what are those? Well, 48 is H, 65 is E, 6C is L, 6C is L again, 6F is O, 00 is a null byte, and all the rest are also null bytes. Null bytes are the same as the value 0. Null byte is literally the 0 byte, or the value 00. That's what a null byte is. Whenever you have a string representation, you have the ASCII table, and if you have the ASCII value of 0, that's the null byte, that's where the string ends. So this data section, that's what this data is all about. Now if you would look at it as values, that's simply this full hexadecimal number translated to a value that doesn't mean anything to you. And because the system is little endian, not going to go into too much detail, but we read from right to left. So when we display these values, the very first value, or the address 10010000, the byte at this address is actually the byte 48 and not the byte 6C. We read the bytes from right to left, and that's called little endian order. So this is our string in memory. So if we load the byte at this address, we will get the first byte of our string. So we won't get the 6C, we will get the 48. So we can simply load the byte at this address, then we can load the byte, and then we get this character. We could load the byte at the next address, so this address +1, and we would get 65, and so forth. So that's the procedure we're going to follow here, is we're going to load the bytes of this string one by one. We're going to check if it's the null byte, and as long as it's not the null byte, we're going to keep going, and we're going to keep a counter of how many times we did this, and that's exactly the length of the string. So let's see this implementation. We load the address of the string into T0, then we load the value 0 into A0. This is our intermediate counter. This is going to have our intermediate result, the length of the string that we've encountered so far. So currently we haven't checked the string yet, so the length is 0. We then load the first character, and if the first character of the string is the null byte, so we load the first character by dereferencing the address in T0. We use the load byte instruction instead of the load word to only load 1 byte and not 4 bytes. If you use load words, then you load this full hexadecimal value, you're loading 4 letters at once. If you load byte, you load the first byte, which is the rightmost byte, which is 0x48. We load that byte. We load the byte 0x48 here, or the first byte of our string, and we store that byte in T1. And then we check, is T1 equal to 0 or not? If T1 is equal to 0, that's the end of our string. So if the first character of our string would be a null byte, this branch would immediately jump to end, and we would have the result of 0. The string length was 0 because the string had no letters in there. But if our string is not empty, well, that means the first character was not the null byte, for example with the string hello. Then we just don't then we just go to the next line of code. We increment our pointer. Our T0 pointer contains the address. First it will contain this address 10010000. We increment that by 1 to make it point to the byte 65, to the next byte in your string. We increment our counter, which holds the length of the string, and then we jump to the loop and we just do everything again. So for hello we will check H, not 0 byte, not a null byte, So that's 1, E not a null byte, that's 2, L not a null byte, that's 3, L not a null byte, that's 4, O not a null byte, that's 5, and then the next byte would be the null byte, that's 6, but we didn't count that one because we branched before we counted that one. So we would have ended at 5, and string length of hello is indeed 5. So if we run this program in A0, you will see the result 5. And where is A0? Right here, and it has the result 5, the string length. So that's how you can write strlen string length in simple assembly.